guess it's not a problem that like SETI has to worry about advertising in that sort of way, like coming up with sponsors and ads in the same sort of way, or is it?
What? SETI
I
has.
mean,
Hmm?
SETI does, I guess, have some advertisements. A couple of years ago, I think now, or maybe I'm getting my timelines confused, but they had a ad at the Rose Bowl, a U.S. football game,
Really?
that was done by Morgan Freeman. You can
Whoa.
look it up on YouTube. It
I'm
was pretty
going to
cool.
look it up. I'm
That
writing this
sounds
down.
amazing. We should get Morgan Freeman to do one of our next ad spots.
Yeah.
Oh, he'll be in
Yeah,
the next episode.
We're a non-for-profit organization that's all research oriented, so.
I see. Okay. We're making too much profit, Benjamin, of our dinky little podcast.
No, I contributed greatly to SETI when I downloaded the SETI
SETI at
screen,
home.
the SETI at home thing like 20 something years ago, and I convinced my friends in our little work group, like 5 or 6 of us, everybody download it. So when we go home at night, it'll just crunch, and it made our little area look really cool because there's numbers and charts just like generating on our screens, and I'm convinced that some good happened. I helped.
I think 1994 or something, I think SETI at Home started.
Yeah, we did this like in the late 90s.
Yeah, it had this like the cool graphic of like lots of different spectra or something,
Mhm.
as if it was processing, as if you could actually see what it was actually doing. But
Yeah,
it had this like
It didn't. I
cool
don't think it did.
techie vibe to it, right?
It was so cool.
Okay, this is the perfect start, I guess, to another episode of Science Actually Presents the Nerd and the Scientist. Here with us today, besides me, Kovi Rose, and our other co-host, Benjamin Salas, is the one and only Chenoa Tremblay, joining us from a SETI site in New Mexico, or from somewhere in...
I'm calling from home. I mostly work from home. My home office is like my control center.
Oh, nice.
I run a project, in New Mexico, but also in South Africa, and I can't be in 2 locations at once. So,
But we're working on that. The scientists will figure that out soon.
But isn't
once
that cool,
you get the
though?
teleportation fixed, let me know.
Oh, okay, that's cool. But isn't that cool, though? You can work anywhere and do this? That's so awesome.
Yeah, absolutely. My team's in the UK, South Africa, various parts of the US. I have students in Taiwan, Japan, and India.
See?
You don't have to be in one location anymore. It's great.
Wicked.
It's so cool. I've had conversations with people recently outside of the world of astronomy who were always surprised to hear that, like, Australian telescopes get used by people all around the world. And, I also use telescopes in South Africa, for example. And you kind of realize that astronomy is one of these great uniting forces to kind of bring people together from different places. That's so, so cool. I could not help but notice that wonderful picture of the VLA behind you.
Yes.
I just
So
noticed
awesome.
the Darth Vader cup. I think that's what that is.
It's actually paint supplies for a board.
Dang, it's not Darth Vader cup. Oh, it looks like it from the side. Oh.
But I've got my aliens too, so.
Okay, that works.
Nice. Okay, so speaking of aliens, we're going to dive right in. Chenoa, where are the aliens?
That's a really good question. We don't know. We don't know what they look like. We don't know what they're doing, but we're trying to find them anyway. We're looking all throughout the galaxy, trying to find signs that somebody else is building radio telescopes somewhere else in the world and sending out beacons or sending out noise of some sort that we could detect.
Awesome. And so your role in this wonderful search to find these beacons is you are managing a project at SETI, the Search for Extraterrestrial Intelligence. What specifically is your project doing?
So I'm a project scientist for 2 major what we call commensal systems. So these are computer systems that are on the back end of telescopes. One is at the Very Large Array in New Mexico. One's on the Meerkat telescope in South Africa. And these get a copy of the digital signals from each of the antennas, and we're simultaneously processing the data while the researchers are doing their own thing and studying whatever their favorite objects are. We're looking in those same fields for signs of technological life. What we're looking for is kind of presentation of some kind of signal that would have a very fine frequency bit of information, something that would be very powerful that could be sent across space, and that we could detect, and we don't have to decode it, but just detect its existence.
How strong would I thought I was muted for a second. Sorry. How strong would a signal have to be for us to detect it? I mean, somebody on another planet using a ham radio, could we hear it, or do it has to be like a strong message that's like just so happens to be sent directly towards us and we're like in the line of fire of it?
It really depends on the distance of that signal, as it will get weaker as it travels through space and time. But one of the things that we think about is, our radio telescopes are sensitive enough, in particular things like the VLA and Meerkat, that you could pick up a cell phone that was going off on Pluto, right? That would be fairly easy for the telescopes to be able to
No
do.
kidding.
But, if we think, we tend to relate everything back to the 1974 message that we sent out with the Arecibo telescope. It's one of the most powerful signals that we purposely sent out towards M13, one of the galaxies. And if we think of that as kind of a power comparison, that's kind of our goal, is to be able to see how far out would a civilization have to be able to detect Arecibo, given enough time. Obviously, if it's traveling 100 light years, it's going to take 100 years before that signal is received. We wouldn't know until 200 years if they sent something back, right? So this is not a quick endeavor. This is not, instant gratification of a field. And so it takes some time. But we're pushing the boundaries in our sensitivities and things like that so that we can push further and further in the cosmos. Our catalogs are typically made up of some of the nearest stars that are identified by something like the Gaia survey. Assuming that at least one planet is around every star, and so it's just kind of a scattershot approach.
And so I guess with the ability to observe commensally, like you said, eavesdropping on whatever the telescope already happens to be looking at, you can observe like all the time, more or less. That must be a metric ton of data. How are you dealing with that?
Yeah, so our systems are designed to process the data in real time. So the signals come in, we're able to calibrate them, we break them up into smaller chunks, and we process them across a large computing cluster. And essentially what we call this is like a matched filter approach. We're making an assumption of what a signal would look like, and then we have the algorithm go and find that type of signal. And so it is not a completely unbiased survey, but it is designed in such a way that if somebody else has a thought of what if it looked like this, we can just plug that algorithm in and run that type of search for a while. But this gives us a tremendous amount of data, like you said, but time on the telescope in comparison to having to wait our turn, in queue with everybody else that wants to use the telescope. And we've designed it so it really doesn't matter what the observing frequency is, what the patch of sky is. Our system will go and look, okay, here's your patch of sky. Okay, what stars are in that patch of sky? Okay, we're going to prioritize these stars. We're going to look towards those. We don't really care what the frequency is because we don't know what the frequency aliens are going to be transmitting at. So we'll just look anywhere. And even if we don't find aliens, we're finding lots of other interesting stuff about the telescope, about the environment, and possibly about new physics. Who knows?
Uh, well, I'm thinking about how when we sent that one message, the Arecibo message, we sent that one time.
Mm-hmm.
And my wondering is if we sent it just one time and whoever's receiving it wasn't looking at that moment, they will have missed it completely. So how is there the thinking that if there was a civilization that's generally trying to reach out, they would broadcast constantly?
I mean, you would hope so,
Yeah.
but they're still going to be spinning, right?
Right. Well,
Unless
yeah.
they're, assuming that there's going to be a time where they're spinning in their solar system. They're probably their planet's possibly spinning on an axis, or they have something like a Voyager that's still going to be spinning within, some kind of some solar system matrix. And so, depending on those timelines, what happens is that you expect the signal to have an acceleration of some sort, and so we can look towards things like that. But yes, it's going to come and go, but you'd hope that they would be presenting it at some period of time. And this is why it's also beneficial for the commensal, because everybody's got their favorite patches of sky, and so we're going back to these repeatedly. So the saying is the absence of evidence is not the same as evidence of absence. So just keep looking,
Ooh,
and
I like
maybe
that.
sometime we'll hit hit the jackpot.
I love that. I love that. And yeah, definitely, I think that um, there are some people who might be inclined to feel somewhat pessimistic based on previous SETI searches over the past few decades. But really, the techniques that are being used now and developed by folks like yourself and people that you work with are sampling so much more space, for lack of a better phrase, that we're only just starting to look properly. I'm curious, the other search methods besides this matched filter approach that you're looking at for technosignatures. What about biosignatures? Looking for those sorts of signs.
Yeah, I mean, there's a tremendous amount of experiments out there that are looking for biosignatures, but there's the school of thought, just similar to technosignatures. We don't know exactly what it is that we would expect to find. It's hard to identify an exact definition of intelligence. It's hard to define an exact definition of life, right? What is required for life, and all we can do is we have a sample of one to base everything in our understanding on, and then we use people's imaginations to try to extrapolate beyond that understanding. But I think I read in a science fiction novel this a tremendous argument about the fact that we're still viewing the world through a straw, and there's only so much information we can extrapolate beyond that view
Mm.
point. And so we do the best that we can. But while we're looking at things like extremophiles here on Earth, things that are living in really crazy environments, things that we didn't think could possibly survive in the deepest parts of the oceans, bacteria that can live in lava, who knows what else is out there. And that's helping us extrapolate what our definitions of life and biosignatures are. And as we're pushing the boundaries from technology to telescopes to our understanding, we're developing a clearer and clearer understanding of how life could perpetuate and develop in other ecosystems.
Not long ago, everybody got very, very excited because what was it? Phosphorus was in the gases of Venus's atmosphere, and maybe we saw organic molecules in some plume off of a moon somewhere or whatever. Like, question is like, how many different little pieces of information do we need to get before we're like, yes, there's something there? These are like one small little thing that could possibly come from life, but there's also other explanations for it. Like, how many different little, do we need three pieces of information? Like we need phosphorus, and we need carbon monoxide, and we need, or dioxide, and we need something else? Then we can say yep. Or do we need, like, we actually have to go and see to be 100%?
I think that's really challenging. I mean, in any scientific process, there's always going to be the skeptical side, and that's what makes us wonderful as experimentalists, because you're constantly testing these theories. If you think of the NASA's new habitable planet archive, right? They have these are our best candidates for potentially habitable planets. And one of these cases was K218b, which I think 2023, I think they had come out that they had found water and methane and CO2 and a few other molecules from JWST and a few other experiments that was suggestive that this planet is particularly interesting. But no one's still willing to say definitively yay or nay. And I think it's going to take much harder evidence. Unfortunately, these things are far enough away that we're not going to be able to send space probes in our lifetime, to get that definitive answer. So the best that we can do is just keep kind of learning and nutting these things out. A lot of these are not direct measurements, they're indirect measurements. So we're making a few assumptions still. So as we're building that technology and getting better at being able to detect a wider variety of molecules and things, I think that will make it a lot easier for us to be able to start pinpointing our. I think they'll still sit in a likely case scenario box instead of a definitive box, but we'll get there, I think.
That's awesome.
Very cool.
Unless we can get a signal or a message that's actually sent that we could translate and it says, yeah, we're over here, and that seems highly unlikely at this point.
It's like a big neon sign, like, over this way.
Yeah, because even if it was an encoded message, what's the likelihood we could translate it into something that we could fathom, right?
Yeah, true.
We can only understand so much. I mean, if you think of the golden record that was sent out on the Voyager space probes, right? The golden record contains greetings in 50 different languages and even brain waves of
Right.
a woman in love, they call it, right? In case that's the realm that somebody that finds the record is able to communicate on. So who knows?
Well, the outside of the record had like lots of like numerical information that helped them know where we are first, and if they could then figure out how to put the record together, then they could find all that other juicy stuff. That wasn't like the primary type of form of communication with the golden record. That's just like buried inside.
Yeah. So,
Ugh,
when
so
the
cool.
aliens find their record player out of their closet and able to
A record
play
player
the
was sent
record.
with it. A record player was sent with it. It's on there. There's a record player on there and a stylus and the
Oh,
whole
there
thing. We're not that kind of jerks. Like, here's a record and a player.
Yeah, and it gives us a map with like pulsars to,
Mhm.
for them to be able to find us,
Yeah, I think like they don't have to necessarily understand exactly what it is, as long as they can like see some sort of sign of intelligence, some sort of pattern. So whether it's the pulsar map or some sort of regularity in the music, or I don't know if we sent primes or that's just a trope that's used in sci-fi, like sending like a series of prime numbers, like anything that can be classified as like not naturally occurring, I guess.
Right.
Yeah, so I think that the Arecibo message contained a bunch of different pieces of information, but one was the numbers 1 through 10, and then the atomic numbers for various different atoms that are important for life here on Earth, like the carbon atom and oxygen and stuff.
Cool. Very cool.
Go.
Benjamin, I believe you might have an ad for us.
Sure. Absolutely. This will be awesome. We actually have a genuine sponsor. Starting off our first episode of our new season. So it's all so exciting. Anyway, are you tired of looking at your boring old toes? Are you sick of socks that scream, I give up on life? Introducing sciencesocks.com, where your feet can finally flex their intellect. You can strut in style with solar eclipse socks. You can wiggle your family of toes with the family of Mars rovers. And don't even get us started on the variety of James Webb Telescope socks. Because let's face it, there's no pattern like a science pattern. Plus, if you visit sciencesocks.com/nerd, 10% of proceeds go straight towards STEM classes for kids. That's right, you're helping the next generation of rocket scientists, robot builders, and sock knitters, all while keeping your toes cozy. So stop staring at dull digits, start socking it to boredom with sciencesocks.com/nerd, the only socks that make you feel smarter with every step. Also available, science-themed jewelry, because your earlobes deserve a little chemistry too. Huh? ScienceSocks.com/nerd, everybody, our genuine sponsor. Welcome, welcome.
I love that.
That's awesome.
We've been going for so long, just like filling that space with ChatGPT generated ads that are silly, but that is a genuine sponsor, folks.
Uh-huh.
And it's so cool, so awesome of Daniel from Science Socks to sponsor us, and also when we asked, like, is there a specific link that we should get people to use for a discount? Something's like 10% if you use this link, will go straight to a STEM charity, and I love that.
It's the best. It's the best.
That's
It's
awesome.
the best. Yes. Speaking of
It
the
matches
best.
my carbon 6 atom earrings I'm wearing.
I was gonna note it. I was gonna say
Oh.
you're wearing atomic earrings. How awesome is that?
So cool. I need more space jewelry. Speaking of the best, I was going to say, you have had a chance over your career to use some of the best radio telescopes across the entire world. I'm curious what your journey was like. Both getting to where you are now, but also like getting to use these different instruments during different stages. I know that you were involved in both the MWA and ASCAP during commissioning. Which I guess thank you for that, because now I get to use ASCAP now that it's up and running. So yeah, like, how was that experience for you? How did you get there?
As also, it always feels like Kovi's reading my notes directly from my screen. I don't know how. I'd like to add, what is your favorite of these observatories or instruments that you've used? All right, Kovi first, then me. Go.
Okay. Well, I've had the most non-standard career path, I think, than of almost anybody you'll meet. Astronomy was a hobby that became a career.
That's beautiful.
I actually worked in corporate research and development for over 20 years in analytical chemistry. So my bachelor's degree is actually in chemistry. I worked in a combination of organic chemistry and pharmaceutical science to inorganic chemistry, working on studying catalytic activity in cars. And then went into working in the mining industry in Australia for a while, running operations in Western Australia and West Africa. And so, but simultaneous to that, starting in about 2007, I took up a hobby of helping build the long wavelength array in New Mexico, which is a low frequency telescope that looks like Christmas trees. That is at the same site
Cool.
as the Very Large Array, but a very different telescope. And I helped work with commissioning or testing some of the software and stuff on that telescope before moving to Australia, which, as Kovi mentioned, I did my PhD working on commissioning the Murchison Wide Field Array for studying biomolecules and technosignatures, both worlds.
Wow.
So my official PhD was doing looking for large biomolecules using the Murchison Wide Field Array, the MWA. But my supervisor was Professor Stephen Tingay, and he recognized that a lot of the same data products could be used for technosignature research. And so we had used my research for both components. So both components are in my thesis. My first postdoc working with ASCAP telescope and the Parkes radio telescope. So ASCAP commissioning for spectral line science, again, for studying chemistry of space and stars. And the Parkes radio telescope, because we had just gotten the ultra wideband receiver for the broadband, and they needed new software for being able to process the data for. We did axion research, so this is dark matter particles, as well as, again, chemistry in space. And so commissioning those two. And then moving back to the US, I worked on building the back end on the Very Large Array for the technosignature research. And I've been working with the team for developing the stuff on the Meerkat telescope as well. and also on the commissioning team for the Allen Telescope Array in Northern California, which was the only telescope in the world to ever be built specifically for the purpose of SETI.
Really?
Yeah.
Love it.
Oh my god! I was waiting like a few times in the middle of that list. Like, but wait, there's more.
Yeah. Yeah, absolutely. A long list of telescopes in there. I don't know. I can't really pick a favorite child at the moment. I feel like I've been living and breathing the cosmic system on the VLA telescope for the last 2.5 years, and so that feels a little bit like it's my current favorite child. But
Current. Yeah.
you know,
I love you all.
yes, exactly. But all of them have, so many tremendous strengths and weaknesses that, being able to use all of these different tools in different ways to be able to build out research problems and answer various questions. Recently, I had been trained on the Green Bank telescope in West Virginia, which is the largest now steerable single dish telescope in the world. It's the size of an American football field. It's 100 meters in diameter. And so, there's some incredible equipment out there, and they cover a wide range of frequencies and sensitivities, and some of them, prioritize large fields of view to be able to study large pieces of the sky at the same time. Others prioritize being able to study really get really sensitive into studies for studying chemistry in space, things like Green Bank. You've got ASCAP and Meerkat that are doing a wonderful job in surveying large patches of the sky uh, at kind of a mid-frequency range. So I don't know. I love them all.
It's hard to choose. I get it.
You got to collect them all. They're like Pokemon, right?
Yeah.
Although when you mentioned LWA looking like Christmas trees, I didn't realize that that's, I guess, kind of a common thread for a lot of dipole antennas. Also, like SKA low, the antennas that are being built for that look like Christmas trees.
They do. They even
It's
hang ornaments on them at Christmas time. So,
yes.
I've seen them decorated in the offices, the ones they use for outreach and stuff.
That's it.
I guess.
That's it.
Yeah,
I'm
I
sold.
guess if you look at like an interferometer of parabolic arrays from the right angle, maybe it would look like a menorah or something like that. So you have like the Christmas tree dipoles, parabolic menorahs. Wonderful. Radio astronomy is only for the holiday season.
Yeah.
Jeez Louise.
Absolutely. And the parabolic dishes make really good projector surfaces, I've seen.
I can watch a movie on it.
I've seen that they've done the ASCAP ones with the different colors of the rainbow and various things. They
Yes.
can project various colors and images. I think on Parkes Radio Telescope, they do some stuff as well.
Given how incredibly sensitive these things are, would they be able to detect that someone's shining lights on them?
Yeah, you have to turn off the electronics to do this. Yeah.
See?
I mean, if you're able to detect a cell phone on Pluto, you'd
Right.
definitely be able to detect a small signature like on the disk.
Yeah. Absolutely.
It's incredibly cool that you've had this journey, and I feel like Benjamin and I were just messaging about it privately, but how many of our guests from the world of astronomy have non-standard paths?
Right. Because we've heard it a few times. I have this non-standard story of how I got from getting interested to where I am, but everyone says it, and that makes the whole idea of astronomy sound wildly just sounds like
accessible.
Fairy tale-ish. Everybody has their little astronomy fairy tale. I didn't expect to take this journey, and here I am. Holy moly!
Yeah, I think I have some students that, follow that linear path of doing like an undergrad in physics and then going on to do a master's in physics or astronomy and then a PhD in astronomy and then they get a postdoc, and that's just like all normal stuff, it feels like it's what most people, in various STEM careers, follow that path. But I think astronomy does tend to pick up, the people that have decided that studying space is really cool and found ways to get there.
I love that. Yeah.
Oh,
It's beautiful. And yeah, I think the good takeaway message for folks listening or watching is just like, if you are passionate about this sort of thing and you've missed some sort of like standard milestone, it doesn't matter. Like, you can always find another way back to it. It's so cool. I love that. All right. So we have a new segment that we have been doing called Questions and Quibbles. It's basically like a rapid fire round of questions. Are you ready?
Maybe. Let's give
it
it a
doesn't
go.
hurt. It doesn't hurt.
all right.
It'll be over quick. What was the weirdest thing that you believed as a kid?
I believed I had an invisible friend named Angel. And she went everywhere, and apparently she was the reason why I'd get in trouble. It wasn't my fault. It was Angel's fault, apparently, is what I used to tell my parents.
Right on. My son
it.
did a similar thing. My son had the invisible boy. Whenever something went askew, it wasn't me. The invisible boy did it.
Yeah, my sister's like that. Every time she dings her car somehow, she'll say, "Oh, it's just a little man with a paint can. He's running around. A little man just painting."
I've
bits
seen
of
that
bread."
guy. That guy's nuts.
Very cool.
Next question. Which teacher had the biggest positive impact on you?
Let's see here. I would probably say that, well, it's a toss-up between two, but I'm going to choose the one in high school. I had a high school chemistry teacher that realized that I had a very good connection to science, and it was the first time that I even considered the fact that I would even go to university. I hadn't really considered it. It wasn't an expectation of anybody in my family. And so it was the first time that I realized that, I actually could do something. I could do something in science. It wasn't until later that I had the confidence to actually pursue a degree in science. But that was, I think, their belief in the fact that I could do stuff and that I was doing a good job with it, I think was the milestone, I guess.
Beautiful. Wow. What was the one scientific discovery that you wish you could have witnessed in person?
Good question. I don't know. I've never really thought about it. I think I've liked to have been more involved with some of the initial, actually with more computing, even though it's not particularly science. Science is done through a lot of computing. I think, being more, I grew up with, with computers to a certain degree, with DOS systems and stuff in the very early days of the internet and things like that. But I think I would have been to have been more involved in understanding the kind of the technical aspects that kind of went into being able to get into the 90s information age, and things around that.
That's cool.
Yeah, that'd be really cool.
If you had to pick one historical scientist to go bowling with, who would it be?
Madame Curie. I think.
Glowing bowling balls. That'd be awesome.
Yeah.
It's like, which one is her ball? Oh, that one. Yeah.
Don't touch it. No.
I mean, the more that I haven't read a tremendous amount about her stuff, but the workings of her mind had to have been extremely brilliant, and the conversations had to have been interesting. I think that would have been fantastic.
Yeah, that would have been cool. All right, the questions get sillier.
Okay.
If you were a sandwich, what kind of sandwich would you be?
What do they call the sandwich? The caprese sandwich. The mozzarella and the tomatoes and the pesto sauce. You
I
know,
like that.
Nice.
it's got
Healthy
some
and
nice
indulgent.
depth and layers to
Healthy.
it. You know.
Gotta
Yes.
give it up for the pesto. What is your most controversial opinion about pizza?
Oh, about pizza. Ooh.
Not in general, just about pizza.
That pineapple belongs on it.
Yes.
You say pineapple does belong on it?
Yeah.
Oh,
Hell
she
yeah.
drew a line.
My new favorite guest.
Totally.
All right. What is your favorite scientific word or phrase?
Good question. Scientific word or phrase? Does the absence of evidence does not equal the evidence of absence count as a
I really like
scientific
that. Yeah.
That's a winner. That's a winner.
Right.
All right, flip side. What's your least favorite scientific word or phrase?
Because that's the way we've always done it.
Oh,
Ooh.
thank you. I cannot stand that. Wow. Okay. Two amazing quotes to take away from this episode already. Okay. What is your favorite useless science fact?
Oh, I don't know. I'm not really good with facts, unfortunately. I kind of work things out. Let's see. Science fact. Are you
Or
putting me
something
on the
that you know
spot?
about the universe that is like maybe fun, but completely useless in the broader
You're at a
scheme of
party and you're at the chips and dip and you just say, hey, you know what? Go.
Yeah. Ah, you know, you say something like that and my mind goes completely blank.
It's the chips and dip. It does that.
It is.
It's a tough one. These are tough, hard-hitting questions. I know.
Mm-hmm.
Yeah. Most stars are made up of carbon.
Oh, that's a good one. Are they? That's
Most are
awesome.
carbon-based
I'm asking
stars.
you like I'm
Yeah.
debating you. Yeah.
There are oxygen-based stars, but most of them are carbon-based stars, from what we
See?
know.
There you go. If you could rename one planet in our solar system, which one and what would you call it?
I'd probably rename Uranus just because every time I go to a high school, everybody giggles at the name. What I would rename it, I don't know, maybe after something in the Zeus or something, you know, just something that is a little bit easier to say to students without them looking embarrassed.
I mean, I guess it's Uranus that has all of the moons that are named after Shakespearean characters, right? So
Yeah,
what
that's
Please
if you
name it
just
Shakespeare.
named? Well, I was thinking you could name it Macbeth, and then you wouldn't have high school kids giggling. You'd have all of the actors freaked out to say it.
yeah.
Or you can go back to its original name. It was George for a short while. It was.
All right,
Pick
last
some, you know, very common name. Let's call it Steve, you know.
Steve.
But it
Yeah.
really was called George.
Yeah, Bill for Bill Shakespeare. I guess that works.
Yeah.
Okay, if you had to, and this is the last question, so don't worry,
Okay.
you've made it through. If you had to sing one karaoke song to save humanity from an alien invasion, what would it be?
Probably the only one I could do would be Twinkle Twinkle Little Star, but I'm not sure that's a karaoke song.
You can make it work. It's for human civilization. We'll make a karaoke song out of it if we have to
Yeah.
do it.
There
Right?
you
Sure.
For sure.
For sure.
Yeah, I guess you could just try to convince them about all of the amazing work that you do at SETI and how much we are trying to, explore and understand our place in the cosmos rather than to be involved in intergalactic or interstellar war or invasion. And maybe they'd
Yeah.
back
There's
off.
nothing more innocent than Twinkle Twinkle Little Star, you know?
That's true.
There you go. it would definitely make up for all of the random junk mail that we've sent them and the nudes that we sent on various probes. So maybe they'd forgive
That's
us.
true. That's true. Yeah.
Chenoa, this has been incredible.
Absolutely.
And very
Thank you
insightful.
so much.
Well, thanks for having me. It's been a lot of fun.
Oh,
It's been great. Got a lot of great quotes, and I'm excited to listen back and to watch back this episode. For folks who are watching or listening and want to either follow you online or learn more about your work or the work at SETI, where can folks look?
So I'm on Blue Sky at Chenoa Chem at Blue Sky, and where else am I on social media at this point? Not a lot of places. It's been a weird year, I think.
Yes.
I'm also on LinkedIn, Chenoa Tremblay. You can find me. My name is at least rare enough that it's usually not too hard.
that's awesome.
Very nice. Benjamin, where can people find you?
You can find me under Science Actually on Facebook and Instagram and Threads and Blue Sky and everything else. I have reached out to and connected with every single Benjamin Salas on LinkedIn, so it's not rare. And there's a lot of French ones, a lot. And you can also find this wonderful show on TikTok and YouTube, also under Science Actually. How about you, Kovi?
Folks can find me at Fun Fact Science on all of the good social media platforms as well as all of the bad ones, although I post there less, if at all. There is no other Kovi Rose on social media or LinkedIn. There is a Kovi wiener dog on Instagram that I have found. No relation. That's not me if you see those photos. But yes, please feel free to connect with us, give us feedback on the episodes, tell us about other guests that you would like to see, and send us questions. And we will see you all next time on the next episode of Science Actually Presents the Nerd and the Scientist.